Hello students, welcome to ACE Engineering Academy. Here I am Ravi Sir, the Faculty of Production subject in this institute, in this ACE Engineering Academy. And as you know that in the today's session, you have to see for the TSPSC exam, the preparation strategy and important question analysis, you have to learn it today, right? Now see, already the one session of production is over and now this is the second session. And for the many subjects, the session is going on. Then all the teachers are telling many things about the preparation strategy. And here also, I am giving you some important tips for preparation strategy for first around 10 to 15 minutes only. And after then, you have to see and you have to answer here in live session of the number of wonderful questions. I will present in front of you the number of wonderful questions and you need to give the answer. I will check it here, right? I will check your answer, yes? And the different number of questions you will get in the today's session, okay? Now see here how to prepare. Yes, just see that firstly, which topic question I am taking here. Casting, welding, NTMM, that is non-traditional machining method, then AMM, advanced machining method, means NC chapter is there, right? These four topic question I will take today, but first see the preparation strategy. And just I come here only with the 2 points of preparation strategy. The first is study hours and second is question bank. Is for whole day, there is one day, in that day how many hours you have to study and how you can manage it, how the maximum hours you can study, and second is question bank. You need number of questions for practice purpose, from where you can get that questions and which type of question you have to follow in that minimum days, right? Less days are required for the exam. Now see the study hours. Yes, now see that this very nice timetable which already followed by me around more than 10 years before, and the same timetable I am presenting in front of you. Now see on the daily basis, whole day, I hope so you are free, and just see you can wake up around 4:45 AM in the morning and you can study 5 AM to 8 AM. The 3 hours you can study very nicely, very good session, morning session. And after then there is 1 hour of break, 8 to 9. In that you can do your bath, breakfast, that work. If you are not staying at home, outside home, then to wash the clothes in 1 hour time you can do that. If some students are staying outside the home, then they need to go outside for the breakfast, then try to prefer idli instead of dosa. Because for dosa they need to prepare some time, but idli is ready, you can save the time there. Yes, and in that 1 hour of span you have to do that all the activities which you need, which is important for us. Now see again there is very nice span, 9 AM to 1 PM, that is a 4 hours of span, very good span. In that also you can study. Then just see the 1 to 2, there is one break, you can take the lunch in that time. And if you are eating at home only, then within the 20-25 minutes, you can eat that, and after then you can take the 20 minutes of sleep. If you are taking the 20 minutes of sleep, that is also very good. If you are taking the sleep for the 20 minutes around, then this span will be good for you, 2 PM to 5 PM, that 3 hour span will be the good for you. Yes. Now the next span 5 to 6, there is 1 hour break, no need to take the 1 hour break also. You can take only the 30-minute break maximum, that is the tea break. Then if you are taking the 1 hour break, then again at night 6 to 8 you can study, that is 2 hours. Then total you can see the 12 hours. Very nicely, effectively you have to study the 12 hours. But to study the effectively for 12 hours, you need to keep the mobile not with you, away from you. Yes, then you can study the 12 hours, and around the 9 PM you can sleep and you can wake up 4:45, 4:50. 8 hours sleep is also required, and if you are sleeping the 8 hour means by this timetable you can sleep for 8 hours also. And if you are sleeping for the 8 hours, then whole when you are studying, there will be no any disturbance. You can study very nicely without any sleep, right? Then this is the timetable you can follow. Yes. Now the main point is that question bank and how to study in that less days. Guys, you know already that you have very less time. Almost your study is completed, and even though your study is not completed, no need to worry. If you are following this 12 hours timetable, then definitely it will be helpful for you. And whatever we taught, that notes you have to use. And what about that question bank? Just see the day by day, the state level examination, questions are also becomes a tough question. It is not like easy. If you see 10, 15 years before, the question was very easy, but nowadays that question is not that easy. Then you can follow that TSPSC, APPSC previous year question, and I think you followed already. You can also follow the GATE theory question. You can also follow the ESC exam theory question, SSC theory question, all are important question. Or you can take any book from the market where the number of questions are given. And now you have to study the question wise. I hope so you completed. Just see these 4 topics here. Just here I am taking the questions of 4 topics. Just I am considering you completed that 4 topic. Then any book, you can take that other any book from the market also, and you can see the question, but you must be careful in some other book. Whatever the book we are providing, that solutions are almost correct. But if you are taking some other book, then the solution may be the wrong. And many students are facing this type of problem. The solution in that book is very wrong. And only see the question from the book and solution from our notebook or from our books. As notes are available, from that notes you can see that solution. And you believe on this solution, because in many but you will get the number of questions in that other books also. And when you are getting the number of questions, and if you are unable to give the answer, then you can go to the notes and you can study that point. And this study is very focused study. And if you are reading only theory whole day for the 12 hours, then many time you may lose your concentration. But you are studying through the questions, then you will not lose your concentration. Because when you are reading the question, definitely you are going to think on that question. If you know the answer, then you are giving the answer and moving to next question. If you don't know the answer, then you need to search in that notes that topic, and you have to study that topic. And in that way, the 12 hours, if you are studying for 12 hours, that utilization of the time will be there. But if you are simply sitting, reading the theory whole day, then only you are reading the theory, but your mind is somewhere. Yes, this should not happen. Yes. Now just see here also, I can see how many students you can reply in live chat also. If you have any queries, then you can ask me here. Okay. Now I am starting with the questions. And firstly, I am starting with the question of metal casting chapter. Yes, now see the question of metal casting chapter. Yes. Yes, I got some messages. Yeah, this is the first question of casting. Give the answer. Very nice question. This is the expected questions. And your revision will be great by studying this question. In casting, in which casting here, the several patterns are attached to a sprue to form a pattern tree. You can see that in this diagram, you can see this is the sprue, this is the sprue, and this is the pattern. Give the answer first. Now you can see that the sprue and pattern is there, but here not only one pattern is there, the number of patterns are there. You can see this is the 1, 2, 3, 4, 5, 6 patterns are there, and at a time by using one mold we can get here the 6 pattern, and that wonderful casting is only one casting, and the name of that casting is, yes, the name of that casting is, yes, one student gave the correct answer, and the name of that casting is very good, Akhil and Vivek. Yes, the answer is investment casting. Answer is investment casting. Guys, we are saying that in the investment casting, in the one mold itself, we can produce the 10, 15, 20 components, but we can get up to 40, 50, 60, 70, 80 components also in the investment casting. But if they are asking question in exam, how many components, then try to give the answer around 15, 20 only, don't give the 100. 100 is also possible, but that number is not entered into the book, but that 100 number is useful in industry. In the industry, they are making hundreds of components in a one mold only. But if they asked in the examination, you can give the 15, 20 components like that. Okay. Now again, see the next question. Yes, remaining shell mold casting, slush casting, die casting. Here the one component at a time only we can produce, not a number of components. Only one process, unique process is investment casting. Now see next question. Yes, give the answer. For the first question, I got very good replies. Now I am expecting the same replies in this question. Yes, what is the answer? Give me. Yes, very good. One student gave the correct answer, very good. In centrifugal casting process, why we are using the centrifugal casting? We are using the centrifugal casting for making the pipes. For making the pipes, which is made by cast iron material or some other material also. We can make the pulleys. That is, pulleys are in the gym. And that pipes we are making in the centrifugal casting without use of core. Hence in the centrifugal casting, we are not using core. No core is used. Then in centrifugal casting process, what is the correct answer? No core is used is the correct answer. This is the correct answer. Yes? Next options, core is made by sand. No core is used, then what is the question of core? No, core is made by sand, core is made by wood, core is made by plastic, no core is used. And the correct answer is option D, no core is used. Why we are not using the core in the centrifugal casting, guys? Just see, we are making the pipes. Just see, if we have to make the pipe, then by using core method, then the size of core produced will be very large. And to produce such a large core is very difficult to handle. That's why in the centrifugal casting, to produce the pipe, we are never using the core. Many students give the correct answer. Now see the next question. Yes. In a metal casting, solidification of molten metal starts at? Very, very interesting question. Think and try to give the answer. I'm waiting for your answer here. Yes, very good, very good, very good replies. For that, I will tell you one simple diagram here. In metal casting, solidification of molten metal starts at, just see the simple diagram here. In that diagram, you can see that this diagram is cooling curve for a pure metal during casting. This is the cooling curve, is not for alloys. This is the cooling curve for a pure metal. You can see on the x-axis there is a time and on the y-axis there is a temperature. Just in the casting method, just we are taking the some casting material, and that material we are putting into the furnace. In the furnace we are giving the heat, then that solid material, the solid scrap material will convert into the liquid, and that liquid we can pour at some temperature, and that temperature is known as powering temperature. I am writing here the TP, that is the powering temperature we can say. This is the powering temperature. Yes, and I can write here this is the stage 1 of cooling. Now what is happening from powering temperature? As we pour the molten metal into the mold, the solidification is started taking place. Yes, and the solidification, just here the solidification is not started. Here what is happening, when we pour the molten metal into the mold, then continuous the heat transfer is going on, and because of heat transfer the temperature is going to reduce, and we got here the TF. We got here the TF, and the TF is known as freezing temperature. The TF is known as freezing temperature. Now see, here is a liquid at this point, here is also liquid, but here this is the stage 1. In stage 1 what is happening? The sensible heat loss is going to happen. What is the sensible heat loss? You can see that temperature is going to change from powering temperature to the freezing temperature of metal, but the phase remains same. Which are the phases of a substance? Solid, liquid, gases are the phases of substance. Here in the stage 1 you can see that temperature is going to change from powering temperature to freezing temperature, but the phase remains same. Here is liquid and here is also liquid. But that liquid from in the stage 2 what is happening? In the stage 2 the latent heat loss is there. What is meant by latent heat loss? Temperature remains same. Here you can see that in the stage 2 from this point to this point you can see that temperature remains same, but phase is going to change. Here is liquid and here is solid. Then what happened? From this point to this point the liquid is started converting into solid. Then what is our question, guys? Our question is that in metal casting the solidification of molten metal starts at freezing temperature as a liquid. Freezing temperature as a liquid. You can see it here, the freezing temperature as a liquid, and you can see that this point is a freezing temperature as a solid, but where the solidification is started, at this point the solidification is started, at this point just consider if there is 1,000 drop of molten metal, out of 1,000 drop, just consider 1,000 drop of molten metal is there. Out of that the first drop is converted into solid here, then second, then third, fourth, fifth, sixth, 500 up to middle the 500 and up to the end 1,000. At the last point the 1,000 number of drop is converted into solid, and at this point we will get the solidified casted component. Yes, then what is the answer? Where the solidification start? Freezing temperature as a liquid. Freezing temperature as a liquid. This is the correct answer. And here the many student gave that correct answer. That is very good thing. Yes, next question. Sand casting is the example of. The option A is expandable mold. What is mean by expandable mold? Second option is permanent mold. Third is semi-permanent mold. And fourth is all the above. What you can think? The sand casting is the example of. Sand casting is the example of. Yes? Yes, I am checking the answer. Yes, tell the answer. Yes. Yes, some students are giving. Okay, someone is saying A, someone is saying B, someone is saying C answer. Okay, no problem. Yes. Now see that there are two type of mold, especially one is expandable mold and second is permanent mold. What is meant by expandable mold? The mold which are going to break. We are breaking this mold and taking out the casted component. This is known as expandable mold. Understood what is expandable? Just see the sand mold. In the sand casting, we are making the mold by molding sand. We are making the mold by molding sand. We are making the mold by molding sand, and to take out that casted component, we are breaking the mold. Yes, and we are taking out the casting cavity. The mold which we are going to break, that mold is known as expandable mold, and sand casting is the example of expandable mold. What is this permanent mold? The permanent mold is a metal mold. Permanent mold is metal mold. Where we are using the metal mold? In the slush casting, in the centrifugal casting, in the die casting, we are using the metal mold. Next, semi-permanent mold. I can say that the investment casting mold is semi-permanent mold, because in the one mold, we can make the 15, 20, 30, 40, 50 number of components. Then that semi-permanent mold, the example is investment casting. Understood? And the correct answer is expandable mold. Now see the next. More intricate casting geometries are possible with. Now again the wonderful question. You got that what is expandable mold, what is permanent mold, then what you can think. The more intricate castings geometries are possible with. Just I want answer from you. Very, very interesting question and not easy question. I want answer from you. Yes. Yes, I got many answers here. Yes. Some confusion for the student. Now see that the more intricate casting geometries, just see in the permanent mold, we can use the split type of die. Means just see this type of die, we can open the die and we can take the casted component. We can open that die and we can take the casted component. In the permanent mold, but if that component is very complex, intricate shaped component is there, then it is very difficult to remove from permanent mold. And that's why I can say that in this permanent mold, simple shaped component we can produce, but if the component is intricate, then we need to use the expandable mold only. Expandable mold only. Right? Now see the next question. Yes. When more than two pieces are used in a sand mold, the additional part is called as. Now see that the mold is divided into two parts. The first part of the mold or the top part of the mold is known as cope and bottom part is known as drag. Yes, cope and drag. Generally the mold is made by cope and drag. Then in between two there is one line and that line is known as parting line. And that line is known as parting line. Yes, but sometime if the casting is bigger, then we need the cope also, we need the drag also, and some additional part also be required. Yes, and that additional part is known as, what is the answer of this question? Yes, student gave the correct part. Very good, very correct answer given. Yeah, then that middle part is known as cheek, C-H-E-E-K. Yes, then cope, drag, cheek. Now see that this is the parting line. Here is also the two parting lines are there. This is the parting line 1 and this is the parting line 2. Parting line 1 and parting line 2. Yes. Now see here how to remember that A, B, C, D. How to remember that? A, B, C, D. C is at top, D is at the bottom. In that way, you can remember that the cope and drag. Cope is at top, bottom is at, cope is at top, drag is at bottom, and cheek is at middle. Yes, very important question and a simple question. Now see, not easy. Factors affecting the fluidity of molten metal in casting. The first thing is that, what is the meaning of fluidity word? What is the meaning of fluidity word? What is the meaning of fluidity word? Yes, fluidity means, you tell me, I will check. Yes. Now see that. Okay, very good, very good. Yes, very good answer. Now see the factors affecting the fluidity of molten metal. What is the fluids? The fluids are flowing. The air, is we can say the gases or liquids, has the fluidity that can flow. The air can flow, the liquid can flow, and that is known as fluidity. Then the factors affecting the fluidity of molten metal in the casting, which factors are there which is affecting the fluidity of molten metal in casting? The pouring temperature. Yes guys, correct. If the pouring temperature is more, means if we are giving the high temperature in the furnace, then its fluidity is better. And that's why we have one formula, pouring temperature is equal to melting point temperature plus superheat, or we can also see degree of superheat, or simply we can say the superheat. Yes. Now you can see that if we have to take the example of iron, then what is the melting point temperature of iron? The melting point temperature of iron is 1539 degrees centigrade plus degree of superheat is 152. 200 degrees centigrade, 150 to 200 degrees centigrade, then here approximate we can take the temperature of 1700 degrees centigrade, and that will be the pouring temperature. Then if the temperature is high, then the fluidity is good. If the temperature of molten metal is less, then it will not flow properly because its viscosity is going to increase. Yes, then it is correct. This is the correct, pouring temperature is correct. Now, viscosity of liquid metal, just see if the temperature of molten metal is less, then it is more viscous. And if the viscous is there, just see throw the viscous liquid, throw like that, then it will not flow fast. But less viscous, just throw the water, it will flow fast. Then if the viscosity is also there, then it gives the effect on the fluidity. Hence, if it is more viscous, then the fluidity will be less. Hence, the factor affecting the fluidity of molten metal, that is first is pouring temperature and second is viscosity of liquid metal. Third is heat transfer to the surrounding. Yes, that is also very, very important. Heat transfer to the surrounding. Guys, just see, you are pouring the iron at a temperature of 1700 degrees centigrade. But just see, if you are doing that casting in very cold weather, that is 5, 4, 5, 6 degrees centigrade. Now in Delhi, the same temperature is there, 5, 6, 7 degrees centigrade temperature is there. And in such a cold environment, if you are working, then what happens? The heat transfer to the surrounding is more, and because of more heat transfer, what happens? The temperature of molten metal is going to reduce, and as the temperature of molten metal is going to reduce, the viscosity is going to increase. Hence, in this question, that all the options are correct. Hence, I am writing all the above. Yes, all the above. Now, see the next question. Okay, one student asking me, investment casting. Okay, after all the question of casting, we'll see the difficulties. I got some difficulties here, we'll discuss the difficulties also. First we'll complete the all casting question, right? Now see, the riser must solidify. Give the answer first. There is one question about investment casting posted by one student. I will give the answer, please wait. Whatever your queries, after all the casting question, we will see. Try to give answer of this question. Yes. The riser must solidify. The riser must solidify before the casting solidifies. Guys, you tell me, this is the riser and this is the casting cavity. Firstly, the casting cavity started converting into solid, and firstly, what is the molten metal available in the casting cavity started converting into solid. Then the riser can supply the molten metal here. And if the riser, whatever the molten metal available in the riser is first converted into solid, then how riser can supply the molten metal? Not possible. That's why here you can see that the riser must solidify after the casting solidifies. First casting need to solidify, after then riser can solidify. Then the correct answer is option B. A is the wrong option. Before the casting solidifies. If the riser is solidifying before the casting, then how riser can supply the molten metal? No, riser can't supply the molten metal. At the same time of casting, guys, this is also not wrong. It is also possible. But if the option B is not given in the question, then we can go with option C. But here, the option D is also not like that. B and C, if they are giving the option, D as B and C, then I can write the answer D. But here only the one option we have to choose, and a more correct one is after the casting solidifies, correct? Now see next question. Shell molding is a casting process in which the thickness of mold is. What is the thickness of mold in shell molding? Shell mold means what? What is the meaning of shell mold? Shell mold means thin mold. Thin mold. Shell mold means thin mold. And how we are making that thin mold? We are making that thin mold. Yes, we are making that thin mold. And that thickness of that thin mold is very small. It may be 4, 5, 6, 7, 8, 9 millimeter. Such a small thickness of mold we are making. And just see what is given here, around 10 millimeter. Up to 7, 8, 9 millimeter we are writing the answer, but option is somewhat different one. Hence I am writing here the around 10 millimeter. Shell mold means thin mold and it is around 10 millimeter. Yes? Now see the next question. Yes. When two portions of molten metal flow together, when two portions of molten metal flow together, but there is a lack of fusion between them due to premature freezing. What is meant by premature freezing? Just see, the molten metal from this side is also entering here. The molten metal of this side is also entering here, and it is casting is going to fill on both sides. But what is happening? Because of premature freezing. What is meant by premature freezing? What is meant by premature freezing? Yes, what is meant by premature means freezing start takes place before complete filling of casting cavity. Freezing, when the freezing must start? First the casting cavity must be full of molten metal, then the freezing can start, but here the freezing is starting early. When we started pouring the molten metal, then only freezing starts and it is known as premature freezing. And what is this defect is known as? I want answer from you. Very good. I got the correct answer. Very good. Answer is B. This defect, this is the casting defect and it is known as cold shut. Cold shut is the casting defect, yes. Now one student is asked question about the investment casting. He is telling that, sir, investment casting, the complex shaped component we can manufacture. Yes, in investment casting we can manufacture complex shape of component. No doubt into that. And in the investment casting also, no, we are not using permanent mold, no, we are going to break the mold. For what question he raised his query? Just see, for this question, more intricate casting geometries are possible with expandable mold. Sand mold is expandable mold. And investment casting mold also expandable mold. Investment casting mold is also expandable mold. Then in the sand casting also and investment casting also, we can make the complex shaped part. Understood? Right. Now whatever question of casting I want to take, that questions are over. Now see the questions of welding chapter. I need to check, is there any other query? No? Yes. Now see the welding question. Yes, give the answer. Which of the following is not a fusion welding process? What is mean by fusion welding? Listen carefully. What is mean by fusion welding? Just see if the plate is like that. That plate we have to join by welding. In that plate, here we are pouring the molten metal with the use of filler rod. This is one smaller rod known as filler rod. Filler rod is supplying molten metal here. Either it is a gas welding or either it is arc welding. If these edges, these are the edges, These are the edges. If the edges are melting, then it is known as fusion welding. Edges means what? Just see the plate 1 material, plate 2 material is melting, then it is known as fusion welding. And what is happening in that total region? Just see, in that total region, what is happening? There is a mixing of parent material. Parent material means these two plate material and the pillar rod material. Here in that zone where I am showing these lines, there is a total mixing of, this edge is melting, has total mixture of parent material plus a pillar rod material. Hence it is known as fusion welding. Hence it is known as fusion welding. Sorry, this is not fusion, this is the pillar rod. I am writing here pillar rod. Pillar rod. Yes, now you can see that which of the following is not a fusion. Guys, the gas welding is a fusion welding, arc welding is the fusion welding, resistance welding is also fusion welding, hence only the soldering process is a non-fusion welding. And what is happening in the soldering? In the soldering you can see that this is the one plate is there and we have to connect to the second plate. This is second plate. Now what we are doing here, just we are pouring some drop of molten metal here. You can see that some drop of molten metal we are pouring here. But because of that drop of molten metal, this plate 1 material, plate 2 material, here, this material is not melting. If this material is melting, then it is the case of fusion welding. But these parent material are not melting. This parent material is not converting into liquid. Hence, the soldering is non-fusion welding process. See the next question. The temperature in the process is below the melting point of metals. The temperature in the process is below the melting point of metals being welded when no filler metal is utilized. When no filler metal is utilized. You can see that in the resistance welding, we are not using filler rod. And here is also what they are saying, where no filler material is used. In the brazing, we are not using, in the resistance welding, we are not using filler material. But in the brazing, we are using the filler material. In the thermit welding also, we are using the material. Then these two options are wrong. Remaining is A and C. Again, I am reading the question. The temperature in the process is below the melting point of the metals. In resistance welding, we are welding the sheets. This is the sheet 1. This is the sheet 2. The two sheets we are welding, and in the both the sheets, you see if we are using the electrode like that, if we are using the electrode like that on the both the side, yes, then here the material will convert into liquid metal. Hence the resistance welding is fusion welding. Here what they are saying, the temperature in the process is below the melting point of metal. Its temperature in the resistance welding is above the melting point of metal. Hence it is also wrong. Hence correct answer is what? Solid state welding. The correct answer is solid state welding. Yes. You give the answer continuously. Next question. CO2 welding is also called as, CO2 welding is also called as. Now see, for the MIG method, metal inert gas welding, MIG method, we are using the carbon dioxide, that is CO2, as a shielding gas. Shielding gas. That's why the MIG, that is metal inert gas welding, is also known as CO2 welding. Hence option B is correct answer. Hence answer B is correct answer. Understood? CO2 welding is also called as MIG, metal inert gas welding. This TIG, tungsten inert gas. In the TIG, we are using argon and helium. Argon, comma helium, or the mixture of argon plus helium also we can use. The submerged arc welding. In the submerged arc welding, we are using the flux powder. We are not using the inert gases, shielding gases, and in the electroslag welding also the flux powder we are using. Yes. Now see, this is the next question. Yes. Try to give the answer. Yes. Now see, that is a group of fusion welding process that uses a combination of heat and pressure. Combination of heat and pressure, and it is a group of fusion welding. Just see, the solid state welding is not a fusion welding. The solid state welding is not a fusion welding. In the temperature in the solid state welding is lesser than melting point temperature. Then this all ABC, all are the fusion welding process. Then is a group of fusion welding process that uses a combination of heat and pressure. In all the ABC, in all the three methods, we are using the heat, but in the resistance welding, we are using the pressure. Here you can see that here the electrodes are giving very high pressure on the plate. Firstly, what is happening, just see the two, not the plate, two sheets whose thickness is less than 5 millimeter, we can join by resistance welding. This is the sheet 1, this is the sheet 2, we are putting like that, and the electrode is giving very high force, and when the electrode is giving very high force, then only we are giving the alternating current power supply in resistance welding. Which power supply? Alternating current power supply. Then because of resistance here at this point, that material will convert into the liquid, and here the nugget is going to produce. Nugget means weld nugget is going to produce at that point. Nugget. What is mean by nugget? That is small drop of molten metal. That is the nugget is going to produce. Hence in the resistance welding, the heat is also there and the pressure is also there. Hence is a group of fusion welding process. Yes, I am writing the answer. Resistance welding is a group of fusion welding process that uses a combination of heat and pressure. Heat, all three, but pressure only in resistance welding, not in gas and arc welding. Yes, now see next question. Which of the following resistance welding is a non-fusion welding process? Oh, I said that resistance welding, gas welding, arc welding, all are the fusion welding process. But you can see that there is a 4 type of resistance welding. The first is the spot welding, the second is the seam welding, the third is projection welding, and fourth one is percussion welding. That 1, 2, 3 all are fusion welding, but percussion welding is the non-fusion welding process. His correct answer here, the which of the following resistance welding is a non-fusion welding process? The correct answer is what? Percussion welding. Correct answer is percussion welding. Yes. Yes. You the answer of this question? Is a joining process in which filler metal is melted and distributed by capillary action between the faying surface of metal part being joined. Faying surface means what? Joining surface. Faying surface means what? Joining surface. This is the faying surface, means joining. Then you can see that here there is capillary action. Capillary action means what? If there is a crack in the pipe, crack is very small. It may be the 0.1 millimeter, 0.234, 0.5 millimeter of crack, and to repair the crack, we are using the brazing method. Means the molten metal, by brazing method, when we are pouring the molten metal on the crack, then the molten metal will enter into the crack because of high capillary action. What is meant by capillary action? The flow of molten metal through the narrow space. The flow of molten metal through a narrow space is the capillary, it is known as capillary action. And here the correct answer is brazing. Is the joining process in which filler metal is melted and distributed by capillary action between the fine surface. Yes, correct answer is brazing. Yes, again I got some question of student. Just here I am sharing my email ID. If here time is not, if the time, I think the many questions are remaining, that's why for some big queries I am not taking here, but you can mail me. On that mail ID you can contact me. I will try to clear your query here as the time permits. Okay, this is my mail ID, ravikiran d88@gmail.com. Now see the next question. Yes, fusion welds. Fusion welds made without the use of filler metal are known as. Now this is important question. Fusion welds means fusion welding is made without the use of filler metal. Without the use of filler metal means without the use of filler rod is known as. What is the answer? The welding without the use of filler rod is known as autogenous welding. Is known as autogenous welding. Welding without the use of filler rod is called as autogenous welding. Yes, that is the correct answer. Very, very important question. Yes, now see next. The flame in which the oxygen is insufficient for full combustion. There are three types of flame. The first is neutral flame, where the oxygen as to acetylene ratio is equal to 1. Then oxidizing flame is also there, where the ratio of oxygen to acetylene is greater, that is 1.15 to 1.5. But third flame is reducing flame, and that is also known as carburizing flame, where the ratio of oxygen to acetylene is very less, that is 0.85 to 0.95. Hence, oxygen is equal to 0.85 to 0.95 of C2H2 means acetylene. Hence, the flame in which oxygen is insufficient for full combustion is a reducing flame, and that reducing flame is also known as carburizing flame. Yes? Now see next question. Which of the following welding is automated? Tough question, not easy. Which of the following welding is automated? The first option is shielded metal arc welding. Shielded metal arc welding is very, very old process. What is happening in the shielded metal arc welding? Just see, there is one metal, this type of metal is there, and that metal is coated. And that rod, that metal means that rod is supplying molten metal, and that is a manual only. That is manual only. The next, gas tungsten arc welding, it is also manual or automatic also. Manual is also available, automatic is also available. Next, submerged gas welding, it is a fully automatic. It is fully automatic. Then correct answer is, which of the following welding is automated? It is submerged gas welding is the automated. Next, oxy-fuel gas welding is the gas welding, and that gas welding is also manual. Yes. Now see the next question. The correct sequence of the given material in ascending order of their weldability is. What is mean by ascent? What is mean by descent? Descent means go down, ascent means go up. means worst to top. What is the worst? Aluminum is worst for welding, and mild steel is very good for welding. Why the aluminum is worst? Why the aluminum is worst? Because when the oxygen comes in contact with the aluminum molten metal, it will convert into aluminum oxide. That's why the aluminum is worst. Aluminum is worst, and cast iron is better than aluminum, and again copper is greater than cast iron as well as aluminum, and mild steel is best for. And if you are taking the example of iron, then iron is also very good for welding purpose. Yes, very difficult is aluminum, after then cast iron, after then copper, and it is mild steel. And it has very big data, very big data. If you want that data, then you can mail me, I will send you big data. Number of reasons are there. Each big aluminum 4-5 lines are there, white, so cast iron also big data is there. Then correct answer is option D. Now next question. Now see the questions of NTMM. Give the answer. Non-traditional machining method. Which of the following is mechanical energy process? Tell me which of the following is mechanical. This is the electrochemical energy. Here it is given the grinding. But here around 90% of metal removal is because of electrochemical reaction and 10% is because of grinding. 10% material removal. Here is 90% material removal because of electrochemical reaction. Grinding is a mechanical. But in that method, only the 10% material removal is by grinding, hence I am not giving this answer. Second, electrical discharge. This is not mechanical energy. Electron beam machining. This is also not. Ultrasonic machining is the mechanical energy process. What is meant by mechanical energy process? Where the abrasives are there. And the cutting action is because of mechanical impact of abrasive. If abrasive is giving impact and cutting the material, then these are mechanical energy methods. Next, zigzag holes can be produced. Only one method who can give the zigzag holes, and that method is laser beam machining. Yes, zigzag holes can be produced by laser beam machining. Now see the next. Perfect vacuum is maintained. Out of all non-traditional machining method, there is only one method where we need to maintain the perfect vacuum, and that method is electron beam machining. Very simple questions. That method is electron beam machining. Now see the next question. Which of the following statement is correct for unconventional machining process? What is meant by unconventional machining process? Unconventional machining process means a non-traditional machining method. Yes, and in that method, in unconventional means non-traditional machining method, tool is very important. Tool is never contact with job. The tool is never contact with the job. There is no direct contact. Just see on the lathe machine, if you are working, the tool has a direct contact with the workpiece, and the tool is in contact with the workpiece and removing material. And these are the traditional method, but in the non-traditional method, the tool is never in contact with job. Yes. Next, ultrasonic machining method, USM, has a good machining performance for. Guys, in ultrasonic machining method, we can work on the brittle material. We can work on brittle material. Then you see here, which of the following is the brittle material? Ductile. The steel is also not that ductile like copper and aluminum, but it is steel. Next, refractory material. The ceramic and coal is the example of refractory material, and the ultrasonic machining method is specially used for machining the brittle material, and which is the refractory materials. Yeah, now see the question of advanced machining method. Yes, give the answer of first question. G03 represents the following instruction in CNC programming. What is the G03, guys? What is the G03? Yes, G03 means circular interpolation clockwise. The option A is correct answer. This is the G03, circular interpolation clockwise. This is the G03. Yes. Yes. Now see G08, G09, this is the acceleration and retardation. Yes, what is your answer here? Tell me the answer. I am checking for your answers. Please give the answer. Yes. Correct, correct, correct. Ready, correct. Correct answer is what? B. B is what? Circular interpolation counterclockwise. Yes. And tell me what is the code? G03 circular interpolation counterclockwise means anti-clockwise. And what is the code for circular interpolation clockwise? That code is G02. Very simple codes, G codes and M codes. Now see next question. Technique which uses computer controlled machineries and automation system in entire production process. Technique which uses the computer controlled machineries and automation system in entire process is known as computer integrated manufacturing. Is known as computer integrated manufacturing. The technique which uses computer controlled machineries and automation system in entire production. Just see, the computer integrated manufacturing is the addition of CAD, computer aided design, and CAM, computer aided manufacturing. Is computer aided design, computer aided manufacturing is known as computer integrated manufacturing. And what is that CAE? Computer aided engineering. See next. It is a system that creates a process plan for a new component automatically. There are two process planning. One is retrieval or variant. That is, retrieval or variant is the same thing. And here the second is generative. In a generative cap, the process plan for a new component is developed automatically. Hence the correct answer is what? Generative cap. What is meant by cap? Computer aided process planning. Now see this question. The example of batch production is flexible manufacturing system and a flexible manufacturing system and a flexible manufacturing cell. This is the example of batch production. Yes, there are three types of production. Mass production is also there. The batch production is also there. And the job production is also there. Out of that, the batch production answer is FMS and FMC. Now see next question. Electric motor used for CNC machine which motor we can use for CNC machine. If this is the CNC given, then there is only one option, servo motor is used for CNC machine. If in the question they asked the NC machine, for NC machine which motor is used, then that correct answer is stepper motor. Then that answer is what? Stepper motor. Understood? Electric motor used for CNC machine is servo motor and for NC machine is stepper motor. Yes. Yes, now I want to say you thank you for attending this session, and the throughout session the number of students are there in the today's session, and continuously you answered here. When I am presenting the question, you given the answer, and if you are really queries, then I already share my email ID, then you can mail me on that. I will give you reply or detailed answer of any your query I can give you. And I am telling you thank you again. Thank you very much for attending this session, and all the best for your examination. Thank you. Thank you very much.
And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESC 2020 and ESC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE Online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains